Welcome back to the deep dive. Today, we are investigating a signal that's, well, it's always there, always humming just beneath the surface of our awareness. If you could somehow tune a gigantic radio to the Earth itself, you'd actually pick up this constant, measurable electromagnetic rhythm. People sometimes describe it pretty dramatically, calling it Earth's natural heartbeat.
And that heartbeat, it has an official name, the Schumann resonance, or SR for short. It's a really remarkable, measurable geophysical signal. It operates in what we call the extremely low frequency, or ELF, spectrum. So our mission today is to dive deep into this phenomenon. We want to understand both its, rigorous established physics and the often kind of bizarre cultural life it's taken on. It spans everything from like cutting-edge space research all the way to wellness claims and, even online conspiracy theories.
Okay, let's unpack this then. We should probably start with the basic science. You mentioned this planetary hum. The main frequency sits right around 7.83 hertz. That number seems really precise. Why that specific frequency? Why isn't the Earth humming at, say, 5 hertz or maybe 100 hertz?
Yeah, that specific frequency, it's really a result of the Earth's geometry and electricity. And interestingly, the concept wasn't even measured first. It was predicted mathematically. Back in 1952 by a German physicist, Winfried Otto Schumann. He basically realized that the Earth and its atmosphere created this sort of perfect electromagnetic container.
Ah, the container. That sounds key. So you've got the Earth's surface, which is conductive, right? And then way up, hundreds of kilometers up, there's the ionosphere, that layer of electrically charged particles, which is also highly conductive.
Exactly. Those two layers, Earth's surface and the ionosphere, which sits about 80 to 700 kilometers up, they act like the walls of a giant spherical waveguide.
Yeah.
And the non-conductive area in between. That forms this huge planetary resonating cavity. You could maybe think of it like a massive tuning fork, in a way.
Okay, so we've got the cavity, the tuning fork, but what keeps it ringing? What's providing the energy constantly?
Right, that's the amazing part. It's global lightning. We have something like 50 lightning strikes happening every single second, somewhere on the planet.
50 every second.
Yeah, 50 per second. And each strike acts like this gigantic, continuous, impulsive burst of electromagnetic energy. So as those waves shoot out and bounce around inside this Earth ionosphere cavity, they excite standing waves, but only at specific frequencies, the resonant frequencies of that cavity.
But it's incredible. 50 strikes a second all over the world, creating this single, constant standing wave for the entire planet. And 7.83 hertz is just the main one, the fundamental.
It's the primary, the fundamental mode. But the system also supports harmonics, which are weaker. Think of them like overtones on a guitar string. They pop up at roughly 14 hertz, 20 hertz, 27 hertz, and about 34 hertz. But what's really crucial to understand here is the magnitude. Despite its dramatic name, Earth's heartbeat, this signal is incredibly weak.
Right, you hear heartbeat and think it must be strong, but you mentioned it's measured in the picotesla range. Now, for those of us like me not carrying a picotesla meter today, how subtle is that really?
Oh, it's infinitesimal, truly tiny. We often use the analogy that it's the electromagnetic equivalent of trying to hear a whisper during a heavy metal concert. I mean, it's real. It's absolutely measurable science, but the signal is so subtle you need highly sensitive, specialized equipment just to detect it. It's definitely not something that would ever register on, your phone or your household electronics.
That's a great way to put it. A whisper in a concert. Okay. It's kind of hard to imagine then that such a subtle signal could actually be a powerful scientific tool. But apparently it is. We know Earth-based monitoring is used for tracking global lightning, studying the ionosphere, but you're saying this little Earth whisper helps us study other planets too.
That's exactly right. And that's where the kind of science detective story really kicks off. The theory basically holds that any planet or moon that has both an atmosphere and an ionosphere, so think Venus, Mars, Saturn's moon Titan, or the giant planets, should have its own unique Schumann resonance. And for planets like Uranus and Neptune, the ice giants, SR properties might hold a key to solving a really big puzzle about their composition.
You're talking about figuring out how much water is actually in their atmospheres, which is like a huge unknown for understanding how the outer solar system formed, right?
Precisely. Scientists use numerical modeling, computer simulations, to show that the SR's characteristics, specifically its frequency, and something called the Q factor, which tells you how quickly the wave fades or attenuates, are extremely sensitive to the atmosphere's electrical conductivity profile. And that conductivity is directly linked to the amount of water, either as vapor or ice fraction.
Wait, hang on. Why does water mess with the resonance so much? Is it because water is conductive, so it kind of damps the wave faster, sort of shorts it out a bit?
That's a really good way to think about it, yeah. The higher the conductivity from water vapor or ice crystals, the more the wave energy just dissipates. It attenuates as it travels around the planet. The models show that if Uranus or Neptune had a higher water mixing ratio, let's say 0.1, it could change those Q factors by a huge amount. We're talking a factor of 15 to 40 compared to what you'd expect in a totally dry atmosphere.
Whoa, 15 to 40 times. That is a massive difference. So it means if we could somehow measure the resonance on one of those ice giants accurately, we could work backward to figure out roughly how much water they have, which helps scientists understand the early solar system, maybe locate the original snow line.
It's basically remote sensing on a planetary scale. Exactly. And the possibilities are actually expanding. Historically, you'd think measuring SR on another planet would require landing something there, which is super risky and expensive. But then there were these unexpected observations from a satellite called CNOFS back in 2011. It detected Earth's SR waves actually leaking out into space, outside the main ionospheric cavity at altitudes above 400 kilometers.
Leaking out, so we don't necessarily have to be inside the cavity planet's side to measure it.
Well, if the planet has a magnetic field, the answer might be no, we don't. This was a bit of a breakthrough because it potentially opens up new, maybe less expensive ways to remotely detect atmospheric electricity on distant worlds.
Okay, this is fascinating on the planetary scale. But here's where, for me at least, it gets really interesting. Once scientists establish this, constant, objective electromagnetic rhythm of the Earth, people naturally started asking, is this just physics, or does it actually affect living things? This is the whole human connection part of the story, isn't it?
It is, and the initial fascination, the spark, really comes from an undeniable numerical coincidence. The fundamental frequency of the Schumann resonance, that 7.83 hertz number, well, it's uncannily close to the range of human alpha brainwaves. Alpha waves typically fall somewhere between 8 and 12 hertz.
Okay, that is close. Almost suspiciously neat, you might say. Are we sure scientists didn't just, nudge the numbers a bit to make them fit nicely?
Oh, no. The 7.83 hertz is a calculated average, and it does fluctuate slightly based on things like global lightning activity and how high the ionosphere is on a given day. And alpha waves are also a band, not one single number. But the overlap is real. And since alpha waves are generally associated with states of deep relaxation, meditation, kind of mental coherence,
Yeah.
well, it definitely prompted some genuine scientific curiosity. Could there be some kind of natural synchronization happening?
And that curiosity led to some pretty wild high-tech experiments, didn't it? I was really struck by the NASA research you mentioned. They essentially wanted to know if this background hum, this constant whisper, is actually necessary for biological systems. Do we need it?
Yeah, they took this question extremely seriously. There was a 2021 NASA white paper that recommended ground-based studies using something called the Berlin Magnetically Shielded Room, or BMSR.
The BMSR. Okay, tell us about that. It sounds like something straight out of science fiction.
It kind of is. It's this incredible 8-shell cube made of high permeability metal alloys. It's designed specifically to filter out almost all external electromagnetic interference, including Earth's natural Schumann resonance. I mean, the sheer effort and engineering required just to create a space that's electrically silent. It really speaks volumes about the scientific rigor they're trying to apply here. The idea was to simulate conditions you might find on the moon, for example, where Earth's SR would be totally absent. Then they could see how basic cells, specifically yeast cells in this case, behaved when they were completely deprived of that background signal.
Wow. That is a staggering commitment just to study the absence of this incredibly faint signal. So what did they find? Is life actually dependent on the hum?
Well, the field is still highly debated. It's complex. Some emerging research does seem to show correlations between fluctuations in SR activity and certain bioelectrical processes, like activity in the brain's cerebral cortex. However, many other similar, very carefully conducted lab studies looking at weak electromagnetic fields, trying to see if they affect things like gene expression in human cells or yeast, have often yielded negative or inconclusive results. It's messy.
So on one hand, you've got serious high-tech science spending millions to study the lack of the signal. And then simultaneously, there's this massive industry that's sprung up celebrating the presence of the signal. That's the big cultural split, right?
It absolutely is. This subtle piece of atmospheric physics has been completely, well, co-opted is one word for it. In wellness and spirituality communities, that 7.83 hertz coincidence is often taken as direct confirmation of a deep, resonant connection to nature, to the planet. You see it framed as natural harmony. and it gets tied into ideas about spiritual awakening, enhancing intuition, even cell regeneration.
And of course, that feeds directly into a commercial market. You see ads for Schumann resonance generators, special mats, jewelry, all promising to sync your body up with the Earth's natural pulse. Critics, quite rightly, point out that this often involves borrowing precise scientific terms to sell therapies that lack solid, credible clinical evidence. Sounds scientific, but
Exactly. And then we shift into what you might call the controversial edge, the spread of easily verifiable false claims, often built on just misunderstanding or misinterpreting publicly available scientific data.
right, like the first claim, we often see this dramatic assertion that the Earth's rotation is speeding up because the SR is out of control, supposedly making a 24-hour day feel like only 16 hours.
Yeah, that one's physically baseless. It's easily debunked by high-precision atomic clocks and astronomical measurements. While Earth's rotation does fluctuate slightly, we're talking fluctuations on the order of milliseconds, not hours. For instance, the shortest recorded day fluctuation, I think, is just about 1.59 milliseconds shorter than the average 24 hours. Not exactly enough to make you feel like you lost 8 hours.
Okay, so the day isn't shrinking drastically. Then there are the claims about the frequency itself spiking wildly, reaching astounding levels like 120 hertz, and supposedly causing physical symptoms like tinnitus or vertigo, which then get rebranded online as ascension symptoms.
Again, the idea of the fundamental frequency hitting 120 hertz is simply incorrect physics. It's not how resonance works. These claims often come from people misinterpreting the monitoring charts, the spectrograms, that are published online by places like Tomsk State University in Russia. When those charts show like solid black vertical bars or big white patches, certain social media channels jump on that and claim it shows some massive global energy event, or even that the scientists are hiding data suppressing it.
But if you actually read the documentation from the monitoring site itself, what do those bars really mean?
Usually, nothing nearly so dramatic. Those black bars or whiteouts typically just mean the station recorded no data during that period. It could be a simple technical glitch, routine maintenance, or maybe the sensors got saturated by a strong local lightning storm right near the station. It's usually just a data gap, not some cosmic cover-up.
Okay, that makes sense. And the final piece of the conspiracy puzzle often involves HAARP, right? The High Frequency Active Auroral Research Program in Alaska.
Ah, yes, HAARP, the perennial favorite. There are persistent claims that HAARP is somehow artificially creating these SR spikes. But again, we just need to check the basic physics. HAARP operates in the megahertz range, that's millions of cycles per second. The Schumann resonance operates in the single-digit hertz range, just a few cycles per second. The frequencies are vastly different. There's just no known physical mechanism that connects the two in the way these claims suggest.
And when you follow the trail, there seems to be a pretty clear financial incentive behind spreading some of these more alarming, misinterpreted ideas.
Absolutely. The anxiety generated by sharing these dramatic, often scary-looking charts. It gets channeled directly into sales funnels. People are pushed towards buying expensive solutions, whether it's supplements, grounding mats, or special frequency-generating devices. It often looks like a form of psychological manipulation that's just weaponizing misunderstood scientific terms for profit.
So when we step back, we're left with these two really distinct realities for the Schumann resonance. On one side, it's this measurable, frankly beautiful scientific reality, Earth's constant, quiet hum powered by global thunderstorms. And it's a genuine, useful tool for everything from climate research to exploring other planets.
And then on the other side, you have this phenomenon feeding a massive market of metaphysical speculation, where rigorous science gets either cherry-picked, misunderstood, or deliberately twisted, often for profit, or maybe just psychological comfort. I think the main lesson here is really the importance of distinguishing between that objective, rigorous science, which celebrates the natural world's complexity and uses these signals for real research, and claims that just borrow scientific language without credible evidence to back them up.
It's definitely a powerful reminder that the actual universe, the real physics, is often far more strange and complex and frankly more interesting than a lot of the manufactured mysteries we sometimes create around it.
Absolutely. And maybe think about this for a final thought. The truly fascinating scientific question isn't whether the SR is some magical cure-all frequency. Instead, what does the existence of that serious, rigorous scientific effort like building the Berlin magnetically shielded room, just to study the absence of this incredibly weak, constant planetary frequency, what does that suggest?
It suggests that maybe there are still subtle, genuine and perhaps still undiscovered ways that simply living on an electromagnetically active planet does affect us biologically. That seems like the real mystery here, the one worthy of careful, rigorous scientific pursuit. We might not have all the answers yet, but knowing which questions are the real ones to ask is maybe half the battle.